This conference will now be
Let me
recorded.
start with the sixth rule of the pointer. Let us quickly brush up the first 5 basic rules. So it is just to make sure whether you have got the topic properly or not. So we will first do the first 5 rules quick brush up, and then we will move to rule number 6 of the pointer. Now to start with, the very first rule of the pointer says pointer is an integer. So let me not show you what the rule says. So the very first rule of the pointer says pointer is an integer. Now tell me, why should you go with the pointer variable? Why is a pointer required? Come on, why do you think is a pointer required? Please answer. And please don't give the answers to the presenter or private or organizer only. Please make use of the normal chat box where everyone should be capable of seeing your answers. To store the address, okay. To store the address of a variable, fine. In order to achieve pass by reference, okay. To store the address of a variable, yes. So basically, pointer is something which is used to access the memory in an efficient manner, and pointers are the variables which are meant to store the addresses of another variable. So any pointer you take, it is to store the address of the variable. Now, if my intention is to store an address of an integer variable, I have to declare an integer pointer. And if my intention is to store the address of a character variable, I have to go with a character pointer. Now, depending on the type of the pointer, I'm going to have, depending on the type of the address I want to store, I'm going to take that particular type of the pointer. So how to declare that pointer? How can we declare the pointer variable? Only star p. Come on, what is the syntax of declaring a pointer variable? Yes. So first I have to specify the data type. Let me consider it as int, then star, then I have to specify the name of the pointer, which is ptr, like this. So int star ptr, ptr is the name of the pointer, and this pointer is meant to store the address of an integer. Now, how do you read this statement is, we always read it from the right hand side. PTR is a pointer to an integer, or you can say PTR is an integer pointer. So both of them are the same, but good practice is PTR is a pointer to an integer variable. So that is how you always read it. Now, PTR is meant to store the address of an integer. If you want to store the address of a character, you can go with the character pointer, and the name of the pointer is completely up to your choice. Now, the second question. How much memory is allocated for the pointer here, whether it is PTR or CPTR? So, how many bytes of memory is allocated for the pointer variable? Based on the architecture, okay, yes, it is system dependent. And how much do you think it is? If it depends on the system, yes, it is. So remember, whatever is the type of the pointer, okay, so it doesn't matter what type of the pointer it is. You can take an integer pointer, a character pointer, a float pointer, a double pointer. All of them are meant to store the address. So your pointer should be capable of storing any given address in the memory block, and the size of the address is going to vary according to the bitness of the system. In case of a 32-bit system, size of address will be 4 bytes, and in case of a 64-bit system, size of address will be 8 bytes. So size of the pointer completely depends on the bitness of the system. 4 in case of a 32-bit system and 8 in case of a 64-bit system. So my system is 64 bytes. Hence, whichever pointer I take will get 8 bytes of memory allocated. So that was rule number 1 of the pointer. Pointer is an integer. If you basically look into the pointer variable, you will see some numeric digits being stored. and that corresponds to the address of a variable. Okay, that is the only difference. So to look practically, it will be some integer number itself, but it corresponds to address of some variable. Hence, pointer is always meant to store the address. So pointer is a variable which can store the address inside it. Pointer will get 4 bytes of memory allocated in a 32-bit system, 8 in case of a 64-bit system, irrespective of the data type. So that was rule number 1 of the pointer. Pointer is an integer. What was rule number 2 of the pointer? What was rule number 2? What was it actually talking about? We have got around 46 participants, but I hardly see 4 to 5 responding. I don't know what is the issue behind this. Okay, yes. So rule number 2 of the pointer is talking about the referencing and the dereferencing operator. So we have referencing operators, we have dereferencing operator. So what is that operator we use to represent the referencing operator? What character do we use to represent the referencing operator? It is ampersand, and dereferencing operator is represented by star. So on what type of variables the referencing operator can be applied? Please understand, reference operator can be applied on any variable. Okay, so you literally can apply this on any variable. And what does the reference operator give? What does the reference operator actually give? When I say ampersand of PTR or ampersand of A, ampersand of B, it gives the address in which the variable is being present. So reference operator gives the reference of the variable. How to give the reference? It gives the address of the variable. So referencing operator always gives the address of a variable. And what about the dereferencing operator? Okay, so dereferencing operator is going to get the value present inside that particular address. Okay, so dereferencing operator should be applied only on pointers, and whenever dereferencing operators are applied, you are going to go to a specific location and fetch the value, or you will go to the specific location and write the value. So whenever dereferencing operator is used on left hand side of the assignment operator, then you are trying to write a value to that address. For example, assume there is an integer variable called num. Okay, then I take integer pointer called ptr storing the address of num. Please don't get confused with this statement. The name of the variable is just ptr. It is not star ptr. Okay, so first I have got is an integer variable called num. Then I have taken a pointer variable called ptr. So this integer variable num has got 4 bytes of memory allocated from the address 1000. And this ptr, assuming mine is a 64-bit system, has got 8 bytes of memory allocated from the address 2000. Now inside this ptr, I'm initializing it with address of num, which is 1000. So whenever I write star ptr on the left hand side, I'm going to go to the address whatever ptr is storing, and I will write the value whatever is being specified. So star ptr means star of 1000. Ptr is having the value 1000. I'm telling go to address 1000 and have it return with the value 100. So I will go to address 1000 and have it return with the value 100. Now similarly, rest of all of the times whenever star ptr is being used, I am going to dereference. After dereferencing, I'm fetching the value. So for example, in this case, percentage D equivalent of star PTR. PTR is having the address 1000. Star PTR means star of 1000. I'm telling go to address 1000, and this time this percentage D is expecting something. So I have to go to address 1000 and fetch the value. This time it gives me 100. So percentage D equivalent is going to have 100 printed as an output. So that is the dereferencing operator. Referencing operator is ampersand, dereferencing operator is star. Can you tell me what does ampersand of PTR gives me here? What does ampersand of PTR gives me here? Yes, it is giving you the address of the variable, which is 2000. So it has to give me 2000 printed as an output. So that is about the referencing and the dereferencing operator. Now we have got the third rule of the pointer. What did the third rule of the pointer talk about? What was the third rule of the pointer? Pointer holds the address. Okay. Can you be a little specific? We have statements framed. Yes, pointing means containing. Okay. So pointing means containing. Now, it is a very simple statement. If you look at the example here, pointer is having the address 1000 stored. So pointer will be pointing to the address whatever it has got stored. And in that address, there might be a value of your need, or it might have been written with some garbage value. But pointing means containing. So pointer will have an address, and that address will definitely contain something, either something which is required for our operation or maybe something which is garbage. So that was rule number 3 of the pointer. What did rule number 4 of the pointer talk about? So what is the fourth rule of the pointer? Or what did it talk about? Okay, so it was talking about the type of the pointer. Okay, so it was actually talking about the type of the pointer. Now see, in the first rule you must have understood that whatever is the type of the pointer, it is going to remain same. The size of the pointer remains same irrespective of the type. Whether you take an integer pointer, a character pointer, a float pointer, double pointer, every pointer gets 4 or 8 bytes of memory allocated depending on the bitness of the system. Okay. Now the question comes is, why do we need the type of the pointer? If all of the pointer are anyways getting the same bytes of memory allocated, why is the type of the pointer required? Now tell me, instead of me taking some technical example, I will give you a non-technical example. Let's say I ask you to go to a house of door number 101. Okay, just an example. I ask you to go to a house of door number 101. Now, looking at the address 101, looking at the door number 101, can you decide how many people are staying in that particular house? Can you decide how many people are staying in that particular house? So, no, you cannot decide. Second question, looking at the door number 101, can you decide what type of people are staying, whether it is an Indian staying in the house or an NRI staying in the house, or whether there is a American staying in the house? Is it possible to know what type of people are staying in the house with just the door number? No. Similarly, when you tell your compiler, when you say assume PTR is some random pointer variable having the address 1000 stored, you tell your compiler to go to address 1000. Now looking at the address 1000, first of all, do you think the size of address of character is 1 byte? Do you think address of character is 1 byte? No, right? Address depends on the bitness of the system. So I mean, looking at the address 1000, compiler doesn't know how many bytes should it be fetching or how many bytes should it be writing. Because looking at the address, I cannot easily define or justify. Okay, so address of ch is not 1 byte or 4 bytes. So looking at the address, it is highly impossible for the compiler to know what type of value is returned in the address, or how many bytes of data is returned from that address. So to make the compiler aware of it, we have to specify the data type. Now, if I have taken a pointer of type integer, whenever I dereference the integer pointer, compiler knows that from the address 1000, there must have been an integer return. So integer has been returned in 4 bytes. Hence, compiler has to fetch that 4 bytes of data from the address 1000. So type of the pointer tells how many bytes of data has to be fetched or how many bytes of data has to be returned from the given address. Okay, the type of the pointer is going to tell how many bytes of data should be fetched and how many bytes of data has to be returned from the given address. So that is the need of type of the pointer. Can you tell me another reason why type of the pointer is required apart from this? There is one more reason why type of the pointer is actually required. Where do you think it is? Come on, where else do you need the type of the pointer? Have you done the pointer arithmetic? Have you done the pointer arithmetic? Applying arithmetic operators on pointers? Yes. So while doing the pointer arithmetic also, don't you think you need the type of the pointer? Because if I have taken an integer pointer called ptr, what happens if I do ptr plus plus? Or what happens if I do ptr plus 1? What is it dependent on? So it is always dependent on size of the data type. Okay, the size of the data type. So the type of the pointer is also required in order to perform the pointer arithmetic. So whenever you have to perform the pointer arithmetic, you might have to, you definitely need the type of the pointer. So pointer arithmetic is another reason why type of the pointer has been required. So these are the first 5 rules of the pointers you have already discussed. Have you got any doubts in this? Everybody please confirm because I have to move to the next topic. Okay, fine. All right. Now let us move to the next rule of the pointer, which is nothing but it is talking about something called as the null pointer. Okay, this is actually talking about something called as the null pointer. Now, before I take you to the null pointer, let me give an idea of why null pointer is actually required. There is a reason why null pointer is actually taken. Let us understand this. Assume I take an integer pointer called ptr. Okay. Now, how many bytes of memory is allocated for ptr? Okay, so assuming mine is a 64-bit system, I always expect you, whenever I ask you the type of the pointer, please have a habit of saying 4 or 8. Okay, so don't fix for anything like 8. Please make sure you are setting it as 4 or 8. Okay, Babu is saying when we don't need to assign any address to the pointer, we use star ptr is equal to null. Okay, so I'll come to that point. Please wait. So pointer is going to get 4 or 8 bytes of memory allocated. Now assume mine is a 64-bit system. Hence the pointer in my system is going to get 8 bytes of memory allocated. Assume from the address 1000. What will be present inside this pointer variable by default? What do you think will be present inside this pointer variable by default? I haven't initialized the pointer. Do you think there will be a 0 present? No. What do you think? Yes, it has to be a garbage value. Okay, so yes, it is an address because it is a pointer. Whatever is stored inside it is a garbage address. So what is being stored here is not 0. It is being assigned with some garbage address. So the pointer here is going to have some garbage address inside it. Now assume that garbage address is 1, 2, 3, 4, 5, 6. I'm just randomly taking, this is the address. So that address is somewhere here in the memory block. Okay, the address is somewhere here in the memory block. Now according to rule number 3 of the pointer, pointing means containing. So pointer will be pointing to that particular address. Now this PTR, what it has is a garbage value. Assume when you do star PTR is equal to 10. Okay, then you do printf percentage d equivalent of star PTR. Okay, you do something like this. So what are you expecting as an output from this example? You are expecting 10 here as an output, but there is a problem linked to it. Please understand. I'm going to address whatever PTR has got stored. So PTR has got 1, 2, 3, 4, 5, 6 address stored. I will go to address 1, 2, 3, 4, 5, 6 and I try writing 10 inside it. First of all, do you think this address 1, 2, 3, 4, 5, 6 is a valid address? Do you think this address is a valid address? Valid address in the sense I'm talking about whether this address belongs to you or not. Okay. See, it is completely unknown. You don't know whether this address is in your programming limit or it is somewhere else. Okay, you have no idea. So assume first time you execute this code. Okay. So after I have executed this code for the very first time, PTR is having the address 1, 2, 3, 4, 5, 6. Now that address into that address you go and have it return with the value 10. When I do star PTR in the printf, I go to address 1, 2, 3, 4, 5, 6 and fetch an integer. So it gives me 10. Okay. This is one scenario. Now after some time, assume you execute the same code again. Okay, assume you execute the same code again. So this time the PTR has a garbage address like 45678. So this is the garbage address. And assume that garbage address is somewhere here and pointer is pointing to that particular address. Now assume this address is not under your program limit. Okay, assume this is not under your limit. So when I try doing star PTR is equal to 10, this time it actually gives me a runtime error called as the segmentation fault. Okay, this gives me an error called as segmentation fault. Please understand what is happening. So PTR is an uninitialized pointer variable. Okay, and when you tried writing for the first time, whatever PTR got an address inside it was in your programming limit. That was luck by chance. So you went to that address and had it returned with 10. Later dereferencing, you got the 10 back. But again, for the second time, if you execute the same code, PTR is having the garbage address as 45678, which is not under your programming limit. So it is out of your limit. When I do star PTR is equal to 10, it is not possible for me to go to some random address which is not in my limit. Hence, this gives me a segmentation fault. Now you will get confused. First time when you executed, you got 10 printed as an output. Second time when you are executing, you are getting segmentation fault. Okay, so first time I'm getting 10, but second time I got segmentation fault. So what you will do, you will start debugging your code. Okay, you will try analyzing your code. You will start debugging your code. Now when I start debugging the code, what actually happens is you will try seeing what is present inside the pointer variable. So you will see that inside the pointer variable you have got an address. Even though you have got an address inside it, you will think previously I got the proper output, but why am I getting this error this time is the question. Okay, it will think, why am I getting the segmentation fault? You will start thinking, previously I got 10 properly, but why am I getting the segmentation fault this time? So you will start thinking. Now, there is a problem associated to it. So this pointer variable, which has not been initialized with a valid address, is called as a wild pointer. Okay, this is called as a wild pointer. It is wildly pointing to some random address in the memory block. Now, dereferencing a wild pointer doesn't matter whether you are trying to write or read. Dereferencing a wild pointer always gives you an undefined behavior. So undefined behavior means you might end up getting the expected resultant, or you might end up getting the segmentation fault. Okay, it is going to give you an undefined behavior. And dereferencing, okay, even if you debug, it is difficult to identify why exactly is this happening. Okay, even after trying to debug, it is difficult to identify. Now, how to solve this problem? This all happened because I took a wild pointer. Okay, if I made sure pointer had some valid address, then I wouldn't have got this undefined behavior as an output. So remember, in order to avoid the undefined behavior, to get the defined result, you have to initialize this pointer with null. When you're not sure of what address you want to store inside the pointer variable, you're going to have it return with null. Okay, so you are going to have it initialized with null. Now what happens? You are initializing this with null. Okay, so you are initializing this with null. Now what happens is, inside the pointer variable, you have got return with null. Now what is this null? This null is just nothing but null pointer constant. Okay, null pointer constant. To be very specific, this null is just nothing but a macro. Okay, you have no idea what a macro is. For now, just assume it as address 0. Okay, this null is just nothing but address 0. Okay, so this address 0 is in fact nothing but 0, which is typecasted to void star. Okay, I'll talk about this later. What is this void star? I'll talk about this later, but it is address 0. Okay, now what I'm storing inside PTR is a null pointer constant, which is address 0. Now, whenever I dereference this address 0, I always get a fixed result, which is nothing but segmentation fault. So when I try doing like this now, I will always get a fixed result called segmentation fault. And the reason behind that is, my pointer is actually pointing to an address 0. And this address 0 is the most useless address. Okay, and it is actually a reserved address. Okay, this address 0 is the most useless address, and it is actually a reserved address, and it varies from one system to another, so it need not be 0 in all of the systems. So it is one reserved address for a operating system, and whenever you try dereferencing that address 0, you always get a fixed result, which is nothing but segmentation fault. So now if you take this program and start debugging, you will be able to identify why did you get the segmentation fault. Because pointer is pointing to address 0. Instead of getting some undefined behavior as output, to get the fixed result, and whenever you are not sure what address needs to be stored inside the pointer variable, you can go with the null pointer. Okay, null pointer means pointer value of null or 0. Okay, or it is nothing but null address. Null address or null pointer pointing to nothing. All of them are the same. Now see, I have taken an integer pointer called num. Okay. So where am I pointing to? I have no idea. What does it contain? I have no idea. Can I read or write wherever I am pointing to? I still have no idea. Okay. It is pointing, whether is it pointing to a valid address? I don't know. If yes, can I read or write from that location where it is pointing to? I don't know. If no, what happens if we access that location? It gives an undefined behavior. So the answer for all of this question is pointing to nothing. Okay. So what is this pointing to nothing? It is a permitted location in the system which will always gives you a predictable result. It is possible that we are pointing to some memory location within our programming limit which might fail anytime, thus making it difficult for us to debug. So an act of initializing the pointers to 0 at the time of definition is nothing but null pointer. Okay, is it value 0 or does the pointer contain the value 0? Yes, so it's the pointer which contains the value 0, and in most of the operating systems, programs are not permitted to access the address 0 because it is the reserved address in the operating system. Okay, so as I said, null is nothing but null pointer constant which is defined as address 0. If a pointer is initialized with null pointer constant, it is called as null pointer and it is logically understood as pointing to nothing. Dereferencing a null pointer is illegal. It always gives you a segmentation fault, which is something better than failing unknowingly. Okay, so that is about null pointer. Where and all do we use this null? Whenever you have to terminate the linked list, while indicating the failure of malloc and calloc, you see the null. Where else have you seen this null before this? You actually have seen it already. Where else have you seen this null? Yes, in the strings. Whenever string related function was failing, okay, all whenever strchr, whichever functions were failing, they were returning null. Okay, failures of the string related functions was indicated with null. So we have to reserve one valid address. Which valid address could be most useful? In the operating system, the starting address is 0, which is a good choice. And please understand, it is implementation dependent. It need not be 0 in all of the systems. So this is a null pointer. Int star null, num return to null, or int star num is equal to null. Okay, you have to make sure if you're taking any pointer variable and you're not sure of what address needs to be held inside it, have a habit of initializing the pointer with null so that if you don't have a valid address return inside PTR, if you try directly dereferencing it, you should get the fixed result, which is segmentation fault. And if you debug, that error has to be easily representable. So you should be able to identify why did you get the segmentation fault. So that is about null pointer. Understood this? Everybody, please let me know if you are not getting. And is this page okay? Is this page, is the speed okay for you people? Okay, great. Fine. So that was about null pointer. Hope you got an idea. If you want, can we assign null to multiple pointers? Yes. How much ever pointers you take, if you are not sure of what address needs to be held inside the pointer, To each and every individual pointer you take, yes, you can initialize it with null. Can null pointer and uninitialized pointer give segmentation fault? Null pointer dereferencing always gives you a segmentation fault, but uninitialized pointer, as I said, is called as a wild pointer, and dereferencing a wild pointer gives an undefined behavior. It might give you a segmentation fault, or it might end up doing the operation according to what you have specified. To avoid that undefined behavior, we take the pointer initialized with null. So that is null pointer and null pointer constant. Can null pointer only be used for the sake of error? Uh, in order, see, the major reason of going with null pointer is yes, to avoid the runtime error you come across. In order to avoid the undefined behavior, to get the defined behavior, we make use of null pointer. Okay. Apart from that, you can use to represent the failures of some built-in functions also. Okay. I hope you got this. You can make this noted. I'm just giving you 2 minutes. Okay. So after every topic, I might take 1 or 2 minutes of break. Okay. To make sure you are making the note of whatever we have discussed, please make a note. We will proceed with the next topic. My null pointer gives segmentation fault always, then why we use it. So as I said, in order to avoid the undefined behavior, to get the defined resultant, we have to go with null pointer. It's a safe practice. Okay. In order to avoid the undefined behavior, we need to go with null pointer. Ma'am, pointed is pointed to null before referencing, right? Pointer will be pointing to address 0, and whenever you try dereferencing, okay, you will get the segmentation fault. So after null pointer constant has been initialized, if you want the predictable resultant, you have to make sure pointer has been returned with some valid address. So for example, you after this, it is required for you to write ptr is equal to address of num. Only then you can do the rest of the operations properly. If this statement has been skipped, you will get the undefined behavior, which is why if you write null, this procedure will always give you segmentation fault. Instead of giving the undefined behavior, this will always give you a segmentation fault. So for easy debugging, we are going to initialize the pointer with null initially. Okay, can we proceed? Okay. So the next type of the pointer we have got to discuss is nothing but void pointer. Okay. So now please understand what exactly is this void pointer. Another type of pointer. See, you always wanted something generic, because if you take an integer pointer, a character pointer, a float pointer, double pointer, whatever is the type of the pointer, every pointer is anyways getting 4 or 8 bytes of memory itself. So you will always think, why don't we go with a generic pointer? A pointer which is capable of storing any given address. Yes, you heard it right. So you can go with the generic pointer also, which can store the address of any given variable, for which you make use of a void pointer. Okay, so void pointer is like a generic pointer which is capable of storing any variable's address. Okay, to have an address of an integer stored, we make use of an integer pointer. To have the address of a character stored, we make use of a character pointer. So depending on the type of the variable's address I have got, we take the corresponding pointer variable. But what if I need a pointer which is capable of storing any address in the memory block? So for that purpose, we need a void pointer. So what void pointer does is, it helps me store any given address in the memory block. Now how to declare a void pointer? You make use of the keyword called void. Then you have to specify a star. Sorry. So after void keyword, you have to take a star and you have to give the pointer variable's name. So this is a void pointer. Okay. And similar to void pointer, you can never think of a variable which can store any value. You cannot declare a void variable. So declaring a void variable is going to give you an error. You can never declare a void variable. So maybe you will think, I want to store any given address, any given value inside a variable. If I want to store an integer. If I want to store a character. Like that, you might think you need a variable which can store any value inside it. So for that, you cannot take a void variable. We don't have the concept of void variable, but we can go with the void pointer, which can store any address inside it. Now, assume there is an integer variable called num with the value 10. Okay. I take a void variable. So void star VTR. Okay. I will go with VPTR being the name. Now inside this, I'm going to store address of num. Okay. So first I'll go with, let me copy the same here. So like this, first I have taken a variable called num. Then there is VPTR, which is storing the address of num, that is 1000. VPTR, again it's a void pointer. How many bytes of memory do you think gets allocated for VPTR? How many bytes do you think will be allocated for VPTR? Again, so it is 4 or 8. This VPTR is also meant to store the address itself. So it has to be storing the address from the memory block. Any given address has to be stored. So as you already know, irrespective of the type, The pointer gets 4 or 8 bytes of memory allocated. So this void pointer gets 4 or 8 bytes of memory allocated depending on the bitness of the system. Okay, so this VPTR gets 4 or 8 bytes of memory allocated. What is value of void pointer by default? So whatever type of pointer you take, by default, if you have taken it as a local variable, by default it will be initialized with garbage itself. Okay, the type of the pointer doesn't decide what is returned initially. It always depends on the storage class. Okay, now VPTR is a void pointer which has stored the address 1000. Now please understand the meaning of void. Void means nothing. Okay, void technically means nothing. Now inside the void pointer, what you have stored is 1000. Okay, you are just randomly storing an address inside the void pointer. Now void means nothing. It doesn't belong to any of the data type. Okay, so void means none of the data type. Now when I try dereferencing this VPTR, okay, VPTR is having address 1000. Okay, I'm trying to dereference. While the dereferencing is done, what do you think is compulsory to be known? While the dereferencing is done, what is required? The type of the pointer, isn't it? The type of the pointer is required so that the compiler is aware how many bytes of data has to be fetched or how many bytes of data has to be written. Now, do you think the compiler knows what type of address is this address 1000? No, because it is a void pointer. Remember, void pointer means it is none of the data type. So compiler doesn't know whose address is this 1000, whether it is an address of an integer or a character, or it doesn't know. So remember, dereferencing a void pointer gives an error. Okay, dereferencing a void pointer gives error. Okay, and in fact it gives a compile time error. Okay, dereferencing a void pointer gives a compile time error. You cannot dereference the void pointer directly because void will be representing none of the data type. If you try dereferencing, compiler doesn't know how many bytes of data has to be fetched or how many bytes of data has to be written. So dereferencing a void pointer always gives you a compile time error. Then how to solve this? How to dereference a void pointer? You have to tell what type of address this has to be treated. Okay, I'm telling star of 1000. I'm telling go to address 1000. Now, before I tell go to address 1000, tell the compiler what type of address is this. Whether this is an address of an integer or an address of a character or an address of a float. So you have to specify. So I say it as int star. You cannot write just int. So in that case, 1000 will be treated as an integer value. To say it as an address, you have to add a star here. Now what you are telling? You are telling treat address 1000 as an address of an integer. Now if I dereference, how many bytes will it dereference? So if I dereference now, how many bytes it will dereference? Now that it knows the address 1000 is of type integer, it is going to dereference 4 bytes. Okay, now that it knows the address is of type integer, it dereferences 4 bytes. So whenever you want to achieve generic programming, we make use of void pointers. Generic means it has to be working for any of the given data type. So you achieve generic programming with the help of void pointers. So to the pointer, you pass the address. Okay, whatever address you want, you can pass. It can be collected by a void pointer. But before dereferencing, You have to tell how should it be accessed. So that is about the void pointer. So a pointer with incomplete type is the void pointer. Due to the incomplete type, you cannot perform the pointer arithmetic. Okay, and void pointer cannot be dereferenced. You must use the typecasting operator in order to dereference. Now this says pointer arithmetic cannot be performed on void pointer, but it is dependent on the compiler. In GCC, pointer arithmetic on the void pointers can be applied. Okay, so if you see here, in GNU, C addition and subtraction operators are supported on pointers to void and pointers to functions also. So don't look at this now. Pointers to void. Okay, you can apply pointer arithmetic on void pointers also, because size of void in case of GCC is considered to be 1. Okay, size of void in GCC is 1. Hence, pointer arithmetic on void pointers can also be applied on GCC compilers. So it is dependent on the compiler. Size of the void in some of the cases will be 1. In some of the compilers, it will be 0. So if it is 0, you cannot perform the pointer arithmetic on void pointer. Okay, in GCC, size of void is 1. Hence, you can perform the pointer arithmetic on void pointers. Due to the GCC's extension, size of void is 1. Hence, GCC allows pointer arithmetic on void pointer. And please do not forget, it is compiler dependent. Understood? Got an idea about the void pointer? Okay. So you can note this down. We will look at the example in the slide. What about others? There's only Babu who is saying yes. Is this been clear? And I see very few of you responding. There's Yoganathan, are you there? Swagata, I'm randomly taking the names. Yoganathan, Swagata, Rohit, are you there? Please don't make me take up the names every time like this. Take initiative from your side and please respond when I'm asking something. Okay? Alright, note this down. We will proceed. VPTR cannot store address directly. It can store. So it's a void pointer. It can store any given address. I didn't understand the application of void pointer. So you will realize. Give me few minutes. I'll take up an example where you will understand why exactly is a void pointer used. So please remember the keyword generic. So whenever you want to achieve generic programming, you make use of void pointers. So generic means whatever logic you write should be working fine for any of the given data type. Okay, so that is when we call it as generic. And whenever generic keyword comes into picture, the only thing you have to think of is with respect to the void pointers. Star int star VPTR is correct to dereference and get the value 10. Yes, this is right. So whatever address 1000 is there, I'm telling treat it as an address of an integer and then dereference. So it goes to address 1000 now, and that address 1000 is an address of type integer. So it is going to dereference 4 bytes and it gives me the integer value which is 10. So num has got 10 stored there, so it has to give you 10. Okay. Now, see one simple example. There is a double variable called x which is being initialized with 7.2. Okay, a double variable called x being initialized with 7.2. Now, do you know how to represent the 7.2 in binary? Do you know how to represent the 7.2 in binary? It is of type double. So what do we use to represent any of a given real number in the memory block? What do we use? Yes, we need IEEE 754 format. Okay. So 7.2 is of type double. According to the IEEE 754 format, we have sign, exponent and mantissa bits to be taken. How many sign bits for a double value? One sign bit. How many exponent bits? 11 exponent bits. And how many mantissa bits? 52 mantissa bits. It's not 53, it is 52. So in total, it has to be 64 bits. Now, help me represent 7.2 in binary. How to represent 7 in binary? How to represent 7 in binary? You first tell me this 0, 1, 1, 1. Okay. Then point. Can you tell me how to represent 0.2 in binary? You have to keep multiplying the number by 2 until you get the product as 0. So 0.4. So 0.4 multiplied by 2 is 0.8. 0.8 multiplied by 2 is 1.6. And 0.6 multiplied by 2 will be 1.2. Then again 0.2. It continues. Okay. So it is 0011. So 0011, 0011, 0011, this continues. Now how to bring this data to the standard format? How to bring this data to the standard format? How many directions? Sorry, how many positions should I move the decimal point? And in what direction should I move? To bring it to the standard format. To the left, okay. For how many positions? Yes, 2 positions. Standard format is 1 point anything. Okay. Now this is 1 point 1100 like this, and this is going to continue multiplied by e power, because I moved to the left, 2. Okay. Now how to find the exponent? How to find the exponent? You have to take the standard bias number. Is it 2 plus 11? How to find the exponent? Yes, 1023 plus, in case of float, it is 127. Here it is 1023. Plus 2 is 1025. Help me represent 1025 in binary. Come on. 1025 in binary. 11 bits I want. Okay, fine. So one sign bit, 11 exponent bits. So sign bit is plus, 0 or 1. What is the sign bit, 0 or 1? It's a 0 because it is positive number. 1023 represented in binaries. 1025. This is 1. Then 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2. Okay, so I think it is right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So I have got 11 bits taken. Then I have to fill 52 bits of mantissa. So let me take that 52 bits of mantissa here. So it starts from 1, 100, 1100, 1100, 8 bits. 1100, 1100, 8 bits. 1100, 8 more bits. 8 4s are 32, 40, 48, 49, 50, 51, 52. Because it is a recursive pattern, round it off to the next digit. Okay, so 1101. Now, let me represent this in the hexadecimal format, and ours is a little Indian system. Okay, please understand, ours is a little Indian system. So this is 1 byte. This is another byte of data. This is another byte. This is another byte. So one more byte. One more byte. Okay, like this. So this is, can you tell me the hexadecimal equivalent of this? 0100 is 40. Okay, this is 1C. This is CC. CC. This is again CC. 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 CD. Are you able to get this? Okay. And I have to write this in a double variable. A double has got 8 bytes of memory allocated. Okay, and ours is a Little Indian system. This is double which has got 8 bytes of memory allocated. And according to the Little Indian system, what gets returned in the lowest address? Yes, so least significant byte, which is CD, gets returned into the lowest address. So let me take this double value. Okay, so the name of the variable here taken is X. Assume that X has got the 8 bytes of memory allocated from the address 1000 like this. 1000, this is 1001, this is 1002, this is 1003, this is 1004, this is 1005, 1006, and this is 1007. Okay. Next, according to the Little Indian system, so I should have the least significant byte return here. So CD here, CC, then this is again CC, this is CC, this is CC, this is CC, this is 1C, and this is 40. Understood how 7.2 is stored in the computer's memory? Okay. Now let us take this example. I have a void pointer called VPTR storing address of X. Okay. I take the void pointer VPTR here. This is VPTR, which is storing the address of X. VPTR. Let's say it has got the memory allocated from address 2000. It has got address of X stored, which is 1000. And according to the rule of the pointer, pointer is pointing to that particular location. Now see what and all I have to do. First, I'll copy this. Okay, now see, VPTR is having address 2000. Okay, I cannot dereference VPTR directly like this. I cannot do star VPTR directly. It is going to give me the error. So what I have done is, I'm telling VPTR to be treated as an address of a character. So what I have set 2000 is, I'm telling treat address 2000 as an address of a character. Now when address 2000 is treated as an address of a character, how many bytes do you think it dereferences here? How many bytes it will dereference? It dereferences only 1 byte. Now go to address 1000 and dereference 1 byte. What should you get? Go to address 1000 and dereference 1 byte. I have to get CD. Okay. Second thing, I'm doing VPTR plus 7. On void pointer, I'm performing pointer arithmetic. Is it allowed to be done? Can I perform void pointer arithmetic on void pointer? Yes. In case of GCC compiler, you can do because size of void in GCC is 1. So when I say VPTR plus 7, what is happening? VPTR is having the address 2000. So 2000 plus 7 multiplied by size of void, which is 1. So it is 2007. Now that address 2007, I'm telling treat it, this is 1000. So that address 1007, I'm telling treat it as an address of a character and dereference. It has to go to address 1007. How many bytes it will dereference? Because I'm treating it as an address of a character, it has to dereference only 1 byte, which gives me 40. Now we are not asking what is this format specifier. Percentage X by default gives me hexadecimal equivalent from how many bytes? Percentage X. Percentage x by default gives me hexadecimal equivalent from how many bytes? Percentage x gives me the hexadecimal equivalent of a data from 4 bytes of memory block. So percentage hx is half of it. It gives me the hexadecimal equivalent of the value from 2 bytes of memory block. Percentage HHS is still half of it. So 1 byte. So I will get CD here. I will get 4C here. Now can anybody tell me what does this printf give me as an output? What do you think this printf gives me as an output? CC 1003 and 1004? Okay. Will it give 1003, 1004 as the output? VPTR is having address 1000. 1000 plus 3 is what? It is 3 multiplied by size of void, which is 1. So it is 1003. What type of address have I said 1003 to be treated? I'm telling treat it as an address of type short integer. So how many bytes should it dereference from the address 1003? It has to dereference 2 bytes. So dereferencing 2 bytes gives me CC and CC. Okay. So this should give me CC, CC. But whatever I have fetched from the lowest address is the least significant byte. Whatever I have fetched from the highest address is the most significant byte. So this CC is here and this CC I have fetched is this. Can you tell me what is the output of next printf? It is 1000 plus 0, which is 1000. What am I telling the address 1000 to be treated as? What am I telling address 1000 to be treated as? Address of integer. Now, because it is address of integer, how many bytes should it dereference? 4 bytes. So from address 1000, it dereferences 4 bytes, which gives me CD, CC, CC, and CC. But whatever I have got in the lowest address stored is what? Data stored in the lowest address is least significant byte. So data gets rearranged. This is the least significant byte of the integer, and this is the most significant byte of the integer. So this gives me CC, 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 and CD. Understood this? Okay. If you have got this, please answer these two printfs. Percentage, let's say hx equivalent of why not CD, CC, CC, CC? See, I hope you have known when it comes to an integer num return with 0x12345678, if you represent it in a 32-bit system, starting address gets 78 stored, then you will get 56, then 34, then 12 in a little endian system. And if you get percentage x equivalent, you will get 1, 2, 3, 4, 5, 6, 7, 8 properly. So whatever is in the lowest address is your least significant byte. So I rearranged the data and got it. Yes, I specified it as little endian system. Okay, fine. Now look at this and answer. What is percentage hx equivalent of star sorry, short star of CPTR plus 3 and printf percentage X equivalent of star int star VPTR plus 2. Sorry, VPTR plus 1. Okay, can you tell me what is the output of these two printfs? Third one you want me to repeat? So in third case, VPTR is 1000. 1000 plus 3 is 1003 because it is dependent on size of void. So 1003. I'm treating that address to be of type short. So I have to go to address 1003 and dereference 2 bytes. So I will get CCCC. Come on, can you please answer these two printfs of the same case? What about the first printf? Pavni says this is CCCC and this is CCCC. What about the others? Same answer? Okay, there is a trick here. You are not right. CF, I don't know how VF came. We don't have VF in our representation. Okay, see, I am not earlier. What happened was I was doing the pointer arithmetic. Then I was treating the address of some specific kind. Then I was dereferencing. Okay. What I did earlier was I first did the pointer arithmetic, because of which pointer arithmetic was dependent on size of void. Then I treated the address to be of specific kind. Then I did the dereferencing. But here it's a different situation. I'm first telling whatever is inside VPTR, treat it as an address of short. Okay. So address 1000 is first treated as address of short. Now when I perform pointer arithmetic, compiler is seeing address 1000 as an address of short. So when I perform pointer arithmetic, what should it depend on? Size of what? So because address 1000 is of short variable, this should depend on size of short. Please understand the pointer arithmetic. Pointer arithmetic always depends on type of the data type of that address. Okay, if the address is of integer, pointer arithmetic depends on size of int. If the address is of character, pointer arithmetic depends on size of character. Now, if address 1000 is an address of type short, hence pointer arithmetic should depend on size of short, which is 2 bytes. So this is 1006. I have to go to address 1006, and because it is of type short, I have to fetch 2 bytes. Whatever I have fetched in the lowest address is my least significant byte. So I am ending up getting this as 401C. Are you able to follow this? Okay. If you got this, please tell what is the answer for the next printf. If you have got this, please tell me what is the output of the next printf. Four zero one C C C C C. What about others? 401C C C C C. Yes. See, first you take VPTR, which is having address 1000 stored. Then I'm telling please treat address 1000 as an address of integer. So what should pointer arithmetic depend on? Size of? It should depend on size of integer. Yes. So after this gives me 4. 1000 plus 1 multiplied by 4 is 1004. From address 1004, you have to fetch 4 bytes of data. So it is CCCC1C40. And because of Little Indian system, it is 401C CCCD. Oh, it is 401C CCCC. Okay, but why did we not do like this in the third example? In this case, I first did the pointer arithmetic, then said treat it as an address of short. See the parenthesis alignment. So first we did the pointer arithmetic on a void pointer, then we treated that address to be of type short, and then we dereferenced. But here, before pointer arithmetic is performed, parenthesis is given the highest priority. So VPTR is first treated as address of short, then we are doing the pointer arithmetic, then we are dereferencing. Understood this? Okay. So that is about the void pointer in this. If the last one is VPTR plus 3, what will be the output? In this you are asking? Okay, so here if you take VPTR, okay, the same thing. It actually might end up giving you a segmentation fault. So here what you are doing is, you're doing VPTR plus 3. First you are treating it as address of integer. So it is 1000 multiplied by, 1000 plus 3 multiplied by size of integer is 4. It is 1012. Okay. Then you are telling to dereference, you have to go to address 1012 and fetch 4 bytes. Now, if this address 1012 is not in your limit, it is an illegal access to the address and hence it should give you a segmentation fault. Okay. So that is about the void pointer. Please note this example. We will do one classwork. The same is there here in the slide also. Size of void. Can you please answer Vedangi's question? Can anybody answer what is size of void? Size of void is 1 in case of GCC. Yes. Okay, there is one classwork to be done. We have to write a program to swap any given data type. We will do that. Before that, you can quickly note this down. Okay, can we continue? You don't want me to give the breaks in between? I'm okay to continue if you don't want. Okay, fine. All right, so let us continue. Because if I keep talking, then you will feel you need breaks in between. So I've observed it, which is why I give 1 or 2 minutes of break. Okay, fine. So let us continue. One last classwork for today. We have to swap two numbers of any given data type. Now first, I will directly jump to write the program here. Okay. So first, let me open the terminal. Okay. Now assume I want to swap two integers. Okay. So I have to swap as two integers. I take an example. Let me take try.c file. 1 second. rm.try. Okay, fine. Now see, uh, please help me write the logic for swapping two integers. Okay. So first I'm going with int main. I take two integer variables n1 with the value 10 and n2 with the value 20. Okay. Then first let me print this. So printf, sorry, printf before swapping. Okay. So I will say printf n1 is equal to percentage d comma n2 is equal to percentage d backslash n comma n1 comma n2. Okay. Fine. Then I'm going to call the swap function. What should be passed to the swap function in order to swap two numbers of type integer? Come on, should I pass n1 and n2? Do you think passing n1 and n2 will help me? Do you think I can achieve swapping two numbers without pointers? Come on, is it possible to swap two numbers without address? No, I have to pass address of n1 and address of n2. Okay. What do I need to collect these addresses in the function? Pointer. What type of pointer? Okay, an integer pointer. Now just to avoid the function's prototype, I will write the definition first. Return type is void. Function's name is swap. I collect addresses into ptr1 and integer pointer ptr2. Okay. Now tell me how to swap. Quick. I want you to give me the logic. So I take a temporary variable. Help me do it with the temporary variable. Temp is equal to what? Temp is equal to what? That ptr1 I have to take. What does ptr1 represent? It represents the address. Come on. You're giving address of ptr1 and all. Somebody texted me with address of ptr1. It is not right, guys. You cannot go with address of ptr1. You have to take is the value present inside the address ptr1. So it is star ptr1 and star ptr1 is equal to star ptr2 and star ptr2 is equal to temp. Am I right? Okay. Now this will work fine only for integers. Now how to make it work fine for any of the given data type? If I change the data type here, for example, if I want to swap to float values, don't you think I have to take the temporary variable accordingly? If I have to swap to float values, don't you think temp has to be a float variable then? Void temp cannot be taken. As I said, you cannot go with void variables. That is not possible. Then how to solve this is the question. See, instead of solving, for example, assume n1 has hexadecimal 1, 2, 3, 4, 5, 6, 7, 8, and n2 has hexadecimal A, B, C, D, E, F, F, F. Okay, I want to swap these two numbers. Saurabh is saying hello for what? Saurabh, is there any issue? By mistake? Okay, fine. Okay, so this is num1, okay, which has got 4 bytes of memory. This is num2, which has got another 4 bytes of memory. Now think wisely. When you took a temporary variable of type integer, all of the data of num1 was stored inside that temporary variable. So this has got the memory allocated from the address 1000, 1001. This is 1002 and this is 1003. This address is 2000. This is 2001. This is 2002 and this is 2003. And that is for N2. N1 has 78, 56, 34 and 12. N2 has FF, I'm considering Little Indian system, EF, CD and AB. Okay. Now when I took the temporary variable, all of this 4 bytes of data was stored inside temp. Then all of this 4 bytes was returned into N1 and from temp you wrote it back to N2. Okay. So with the help of a temporary variable. Now think wisely. Instead of doing the swapping of 4 bytes of data at once, what else can you do? Instead of swapping the complete 4 bytes of data at once, what else can you do? Don't you think I can swap it byte by byte? Don't you think I can swap it byte by byte? Yes, I can do it byte by byte. Okay, what is this multi-pointers, Babu? I did not get your answer. What is this multi-pointers? Okay, anyways, can I not do it byte by byte? Okay, not just for integer, take float to float values also. There also you can swap it byte by byte. Okay, from this byte you can swap it byte by byte. Okay, now see how to achieve this. In order to achieve generic, what did I tell to make use of all the time? What did I tell to make use of whenever it is generic? Void pointers. So I take ptr1 and ptr2 to be of type void. Now, in order to swap it byte by byte, what type of temporary variable do you think is required? To store 1 byte, yes, it is character. So I will take the temporary variable of type character. Now again, ptr1 has address 1000, ptr2 has address 2000. I want to swap these two data. So both ptr1 and ptr2 are of type void. To get 1 byte of data, what should I tell ptr1 and ptr2 to be treated as? To fetch 1 byte of data, character pointer, char star. So this is also char star. Okay, char star. And this is also char star. This one is also char star. Now, how many bytes do you think you swapped with this logic? How many bytes do you think you swapped? You swapped only one byte. Now how to go to the next byte? How to go to the next byte? Come on, how to go to the next byte? PTR1 had address 1000, PTR2 has address 2000. I want now to go to 1001 and 2001. Yes, you just have to do the pointer arithmetic, PTR1 plus plus and PTR2 plus plus. Now, how many times should I repeat this operation? In order to swap integers, how many times should I repeat this operation? 4 times. So, along with this here, I pass size of any of the variable, n1 or n2. I collect it into an integer variable here, okay, called size. Now, I run a loop for int I is equal to 0, I lesser than size, and I plus plus. So that is it. Now this logic will work fine for any of the given data type. Okay. If you don't trust me, first let me save this and show how this is executed. You see the output on the parallel window here. So I'm compiling this. So gcc try.c. Okay, no errors, no warnings. Before swapping, n1 is 10 and n2 is 20. After swapping, n1 is 20 and n2 is 10. Now see, I will not touch the function. The same function call, I will do it for the float values. 1, 2, 3, 4, y, 4. Okay, so I'll do it for the float values. See, the variables are, I will take nn1 and nn2. So before swapping, percentage f equivalent of nn1 and nn2. Then to the swap function, I have to pass address of nn1, address of nn2, and size of nn1. So then I will say paste, paste. So after swapping. Now observe, I did not change the logic of the function. So first before swapping 10, 20, okay, let me initialize it with 10.5 and 20.5. Okay, 10.5 and 20.5. So you can see here, before swapping 10.5 and 20.5. After swapping 20.5 and 10.5. So whenever you want to achieve generic programming, you have to make use of void pointer. Understood this? Okay. That is it for today. And to summarize, we discussed the first 5 rules of the pointers. We just revised the first 5 rules and finished the rule number 6, which talks about the null pointer and also about the void pointer. Then we have got rule number 7 to be discussing about, which talks things with respect to static and dynamic memory allocation, which we will do it in tomorrow's session. And I saw when the session just got started, I had around 40 to 50 participants, and now we have around 72 participants. If you people have joined for the sake of attendance, please don't do it. Okay, I'm not encouraging that. So please make sure you are joining on time every day for the class. So 7:05 should be the maximum time you are allowed to join. Didn't understand why bit by bit swapping? Please, can you explain again? Okay, it is not bit by bit. Okay, it is byte by byte. The swapping you have done is byte by byte. And the reason behind that is I wanted to achieve generic programming. Means I wanted to swap two numbers of any given data type. Now, if I have to swap two numbers of any given data type, the temporary variable should be according to the data type. But I cannot change the data type of the variable once it is declared. So instead of swapping the whole data at once, I tried swapping it byte by byte. And this has to work for any of the two variables, whether it is of type integer or float or double, doesn't matter. So it has to work fine for any of the given data type. Example for null pointer, I actually showed it here. An example of null pointer. Why is it actually required? There is no other example which you might have to go for. So to avoid wild pointer, you go with null pointer. In the compiler, okay, so I'll show it tomorrow if you want. Okay, fine. So that was it for today. And if you people have joined late and if you are expecting the attendance, if you have joined for the sake of attendance, as I said, you will not be provided with the attendance. So please make sure you're joining on time. Okay, please have your attendance marked before quitting. That is it for today. Thanks for attending and we will continue tomorrow. One second, let me check. Okay, so let me add the session. It is 7 to 9. Let me keep it as 9:10. How long the C class? You're somewhere at the middle of the module right now. So I at least think around 15 to 20 working classes. Okay, fine. So here is your QR. Please have your attendance marked. Thanks for attending. We'll continue tomorrow. Please join the session on time. From now you will teach. Yes, Anirudh. So I'll be taking over the module from today. Okay, thank you all.